Okay, everyone, welcome back.
Hello.
All right, so we're going to continue in 6.2 today. We'll probably start 6.3. And the next time we'll be doing more of 6.3. So I will say on 6.3, you might want to go back and review partial fraction decomposition from college algebra. I'm going to see if I can find a video from my YouTube list, and then if I can find one, then I'll send it to you all in an email. So if you want to go back and watch something, you can. All right. Any questions before I start? We're good. Okay, so the main ideas from last class were that if we ever get an integrand containing one of these three square roots in it, that we're going to make some specific trigonometric substitution. In this first case, we do x is a sine theta. In the second case, x is equal to a tan theta. And the third case is a secant theta. And then when we do that, a lot of things happen. And then the new integral becomes a trig integral. And then we use what we know about trig integrals to solve. And then we have to get back to x eventually. Last time I did examples. I did examples of the plus, right? The plus I did actually two of those, and then I did one of them where we had the a squared minus x squared. So what I have not done yet is something where we have x squared minus a squared, right? We don't have that yet. So I'm going to start class with that. And I think I'm just going to pick one. Be real careful on these. I have one in my notes that I can do, but I want to do something different. Yeah, okay, let's do that one. This is out of the homework, but I think it's worth us doing. I'll change it up just a little bit. So what if we do something like this? Integral, let's go square root of 4x squared minus, let's go with 9 over x dx. All right, so we run through, we make sure that we can't do this any other way, right? By the way, if it were the other way around, how would you do this problem? If it were this?
U sub.
The denominator are u.
Yeah, you would let underneath the radical be u, and then you'd have a direct u substitution, like a simple u sub. Because if we let this be u, the derivative of it is up here. Well, we're off by a constant, right? Because the derivative of this is just 8x, and we're off by 8, but that's okay, we can handle it. We can't do it here because if we let this be u, the derivative of it is in the bottom. And I told you in the very beginning, when you use u sub, you can't have the derivative be on the bottom. So that won't work. Another thing I want to point out is that students will sometimes do this. They'll say, well, wait a minute, why don't I just kind of like square the top and the bottom? You know, so if I square the top, the square root goes away, I square the bottom, it becomes x squared, right? That's just not a legal move, because when you take an expression, let's just say I took the number 4, right? And then I just all of a sudden square it, you don't have the same thing anymore, right? It's not like multiplying by 1. Multiplying by 1, you do multiply top and bottom at the same thing. That's okay, because you're multiplying. Here, squaring something, top and bottom, changes everything. So you're not allowed to do that. That may seem weird to you that someone would do that, but I mean, that does happen. People will do that.
What about multiplying both the top and the bottom by root 4x squared?
You could do that. You could do that, but I do not believe that would help you in terms of You'll still
Actually
have the
solving it.
square root of 4x squared minus 9. So you still have to do a trig sub, right?
Okay,
Okay, so here we go. I'm going to copy this real quick and bring it over here. And so we are looking at this bottom one, right? It looks like this one, except we don't have a 1 in front of the x squared. So I need to do that first. So what I'm going to do is I'm going to factor out a 4, right, from underneath that root or from in front of the x squared. And that'll turn that to an x squared minus 9/4 all over x dx. And then I can pull the 4 out of the root as a 2. Just slap it out front. And now I have square root of x squared minus 9/4 all over x dx. Now I have it in this form. So the question now becomes what's A and what is our trig sub, right? So let me call on someone here since we've had Joshua, you there?
Yes, I'm here.
Okay, so Joshua, what is A going to be for us?
Let's see here. A or let's see. Well, it looks like you square root, you do x squared, and then you could do a squared for you could do the square root of 9/4.
Okay, good, which is just
Yeah.
so square root of 9/4, which would just be 3/2, right?
Yeah.
Okay, so that's A. And then the trig sub we're going to use, because this looks like this third case, is that we're going to let x be A, which is 3/2, and then secant theta. We all good with that? No? Okay. Yes, yes. All right, now the next part is I always like to just take the derivative of this now. So I know the derivative of x is dx and then 3/2. And then I remember that the derivative of secant theta is secant theta tangent theta d theta. And then I need to figure out what the square root of the x squared minus 9/4 is going to turn into. And last class, I showed you how you can do this by hand, right? I showed you how you can do it by hand. But in the formulas, I actually tell you what it's going to turn into here. Now, be careful, because you can't have this on the test. All right, you can't have this on the test. What you are allowed to have on the test is, I don't have it here, darn it. I can bring it up, hold on. Where is it? What you are allowed to have on the test, where the hell did it go? Is this sheet, where is it? I don't have it. I don't want to go get it. But you go look in your formula sheets. What you're allowed to have has this part, it has this and this, but it does not give you that. So you're either going to have to memorize that for each 3 of these, or you're going to have to go through the details of replacing x with 3/2 secant theta, and then squaring it, and then minus 9/4, and then working that all through to get to the result, which is going to be 3/2 tan theta. I'm not showing that work. Do y'all understand what I'm saying here? I did it twice last class, so I'm not going to do it again. I'm just going to go to the direct result. You sure? No questions? Okay, so I'm going to rewrite the integral now. So this is going to be 2 integral. Now the square root of this stuff we just said is going to turn out to be 3/2 tan theta. That's the numerator. The denominator is x, and x was 3/2 secant theta. And then dx, don't forget dx, dx is 3/2 secant theta tangent theta d theta. So dx was this part, The numerator was this part, and the denominator was that. And now we just cancel things if we can. I see a 3/2 goes away here. Oh, I could have done the other one. Secant theta go away. So I still have a 3/2 here. I'm going to pull the 3/2 out, hit the 2 with it. It'll just turn into a 3. And then all I have is tangent squared theta. D theta. Well, how would you do that?
Identity.
Do what?
How to use the identity.
How do you mean? Use what identity?
Either the power reducing identity or the other identity. I think there's only power reducing identity for this one.
There is a way to reduce this power with the tangent. I've got another suggestion though. How about this? Could we rewrite this? What is that Pythagorean identity? It was tan squared x plus 1 equals secant squared x, right? Wasn't that the identity?
Yeah, and then it should equal tan squared x should equal secant squared x.
Minus 1, right? So if I solve this for tan squared x, I get secant squared x minus 1. Now you're sitting there going, why in the world would we do that? Well, if we rewrite this as secant squared theta, remember it's theta, not x, minus 1, that's the same exact problem, right? That's the same exact problem. But the advantage of this is that I know the antiderivative of secant squared, right? The antiderivative of that is tangent, isn't it? So this is not very, I guess, natural. You have to know where you're trying to, what you're trying to do with this. You're trying to find the antiderivative of tangent squared. You're like, I don't know how to do that. But if it was secant squared, I'd be happy. Oh, well, wait a minute. I can rewrite tangent squared in terms of secant squared. So I do that. And now this becomes, well, let's do the antiderivative. The antiderivative of secant squared theta is tan theta. And then the antiderivative of 1 is just theta, because we're integrating with respect to theta, and then plus some constant. Oops, sorry, my phone's in my pocket. Let me. Now I need to know what tangent of theta is, and I need to know what theta is. And I'm going to go back to the substitution we made, which is right here, right? This was the substitution. I'm going to put it right here. And I'm going to solve this thing for secant theta. So I'm going to multiply by 2, divide by 3. That's secant theta. And then I'm going to create a triangle out of this. Here's theta. Secant is the reciprocal of cosine. So cosine is adjacent over hypotenuse. So this should be hypotenuse over adjacent. So that means my hypotenuse is 2x, and my adjacent is 3. And the reason I'm doing this is because I want to know what tangent of theta is, and tangent requires me to have the opposite side, which I don't have yet. I have to solve this here. So I'm going to solve it. I'm not going to show the work, but this should be square root of 4x squared minus 9. So if you have a question on how that's happening, just, make sure you make a note that you need to figure that out. Ask me questions later, yes? So this now becomes 3, okay, and then tangent theta is the opposite side over the adjacent, which is going to be 3 minus, and now I need to know what theta is. In this last class, I told you that you might run into this in homework, but we hadn't done one like this. To get theta, all I would do is take this and do secant inverse on both sides. Secant inverse of 2x over 3. And then when I do secant inverse of the other side, I just get theta. And so that leaves me here with secant inverse, or arcsecant, however you want to say that, of 2x over 3. And then plus c. Now everything's back in terms of x.
So in some identities that I was doing in the homework, I ended up getting identities of 2x, of 2 theta, 2x. So sometimes we don't print it out. That's what you get.
Yeah,
Is that okay? No, right?
no, that's, I mean, there are some problems where we have to use those identities. Let me do one like that. Do you remember which one you were working on that you had that happen?
Well, I had it happen to me because I could either use the Pythagorean identity, or I could have used the double angle formula.
Okay,
So double angle, no, excuse me. I could have used the sum of difference formula. No, excuse me. Where are you at? The power reducing formula. Sorry about that.
power reducing.
Which has 2 theta, or I could have used the double angle formula.
So do you remember which problem you had that you ran into that?
I can pull it up, but I ended up just doing what you did, but I can show you. Give me a moment.
I'm gonna do one, hold on. I'm gonna find one to do. Unfortunately, these aren't super easy to just make up in your head to make it do what I'm trying to make it do right now. So let me just look for one real quick that'll work out that way. There we go. Okay, I've got one. So how about this one? So were there any questions on that one we just did? Are we all okay with that?
Looks good to me.
Yeah. Okay, so let's look at this one. And let me just make sure last class I didn't do this, right? I did that one. That was our first one. Our second one, third one. Okay, and the one we've done today. So I haven't done one like this yet. All right, so first thing we're gonna do is we're gonna make sure that we know which of these we're gonna use. And we're gonna make sure we can't do it another way, right? But this one we should be able to get using the, oh, is that the same method we just used, right? Same method we just used. So for this one's a little cleaner because I have a 1 in front of the x squared already. So I know I'm going to go straight. I'm not even going to identify what a is. I'm just going to go x is equal to a, which I know is 5, and then secant theta. The derivative of that is going to be 5 secant theta tangent theta, d theta. And I know that the square root of the x squared minus 25 is going to turn into 5 tangent theta. Because I've either memorized that or I would work it out and figure that out. I go to rewrite the integral.
Sir, I had a question.
Yes.
On the test, would you like us to work it out, or we already have it memorized?
If you
Or-
have it memorized, just write it down.
Okay.
You know, just go for it. Yeah. Okay, this should be pretty clean to plug things back in. The top becomes 5 tan theta. The bottom becomes, well, that's cubed, right? So I have to take the 5 and cube it, and then the secant and cube it. And then I have dx, which is another 5, then a secant, then a tangent, then d theta. I thought this one was going to work. Let me double check it. Come on. Did I look at the right one? Yeah, okay, it's right. All right. And now at this point, let's start killing stuff off. So I have 2 5s on the top and 3 5s on the bottom, which leaves me with 1 5. So I'm going to bring a 1/5 out. It leaves me one factor of 5 on the denominator. I have a secant that cancels with the secant cube. That leaves me with secant squared on the bottom. So I have tangent squared on top, theta, over secant squared theta, d theta. And for this one, I could do what I just did if I wanted to. I could turn this into sine and cosines. There's so many different ways I could go about this algebraically, but kind of going off of what we just did on the previous one, I could just turn the top into secant squared theta minus 1 over secant squared theta. Look, this is not the only path that you could have gone down, all right? If you wanted to, you could have done this instead. Sine squared theta over cosine squared theta over 1 over cosine squared theta. I actually like that one better, because then the cosine squareds just cancel right away and you're left with sine squared. But I'm going to stick with this because why not? Okay, we should get the same answer. 1/5. Okay, integral. Now, because we have two terms in the numerator and one in the denominator, we can do secant squared theta over secant squared theta, which would be just 1. And then minus, and then we have 1 over secant squared, right? But what's 1 over secant squared?
Sine squared.
Yeah,
Yeah.
so this is cosine squared theta, d theta. And everyone here should recognize that 1 minus cosine squared is sine squared. Pythagorean identity. Questions on that? 1 over secant squared, that's where I get the cosine squared from. All right, so I think, Lewis, this is what you were talking about. I have sine squared, so we've learned how to do this. This is a power reducing formula. So the first thing I do is, I'm not doing the integral yet. I'm going to rewrite sine squared as 1/2 and then 1 minus cosine 2 theta d theta. That's our power reducing formula. That came from when we were talking about earlier in this section, what to do when we had cosine, sine or cosine to even powers. We used one of these two formulas. That's what I'm doing right here. I'm using this one right here, the sine squared piece. All right, then I'm going to pull the half out, make it a 1/10. Integral 1 minus cosine 2 theta d theta. And I should be able to find the antiderivatives of each of these, because the antiderivative of 1 is just theta. And then this one you just have to be a little careful with, right? The antiderivative of cosine of 2 theta should be sine of 2 theta, but you have to scale by 1/2 to kill off the 2 with the chain rule. So minus 1/2 sine 2 theta plus c. Any questions? Questions? We've done the antiderivative. Here's where you run into an issue. We need to know what sine of 2 theta is, right? And this is where I brought the reference triangle in the past, right? We take this piece right here. This is where we did our trig sub. We would take this and we would create our triangle. Let's go ahead and do that. This becomes x over 5 equals secant theta. So if I go to a triangle, call this theta, secant, we did this last problem. This should be hypotenuse over adjacent. So this should be x, this should be 5. And then solving for the other side, we should get square root of x squared minus 25. But do y'all see the problem? We want to know what sine of 2 theta is. And this triangle doesn't have 2 theta in it, it has theta in it. So I can't tell you what sine of 2 theta is, I can just tell you what sine of theta is. So because of that, the only way to get around it is to realize from pre-cal that we have a formula for this, the double angle formula. That's what we need here. So we need to rewrite this as 1/10 theta minus 1/2, and now this piece here turns into 2 sine theta cosine theta plus c. So again, you have to remember that. It's in your formula sheets. It's a pre-cal formula.
So you want 2 theta to be reduced all the way to just in terms of t?
Yeah, we need, from our reference triangle, I can't tell you anything about what's happening to 2 theta. I can only tell you what's happening for theta. But luckily for us, we have this double angle formula from pre-cal that hopefully your pre-cal instructor told you would come up very big later. This formula right here is used a lot. Sine of 2 theta would be equal to 2 sine theta cosine theta. And see, the nice thing about that is when we look at this now, rewrite this sine 2 theta as 2 sine theta cosine theta, then I'm okay because I know what sine theta is off that triangle. And I know what cosine theta is off that triangle. Because we're talking about theta now, not 2 theta. And these 2.5 cancel, by the way. So let's see if we can keep going. 1/10. Okay, theta. To get theta, I have to go back up to this and do inverse secant on both sides. Get theta. So I'm going to have inverse secant of x over 5 minus, and now I just read off the triangle. Sine is opposite over hypotenuse, so it's this over this, the square root of x squared minus 25 over x, times, because this is sine theta times cosine theta. Cosine theta is 5 over x. 5 over x plus c.
So in some of the answers that you have for the homework, you just kind of left it as that, just 2t or 2 theta. Did you want to go ahead and, like, now that we know this, to just like fix everything again? Or
In some of my homework, I left them as what?
so in the answers that you have for like the homework questions, you just kind of left. We can talk about it later.
Yeah, you'll have to show me specifically because I don't think I have any video of me stopping here. Unless I said on the video, okay, I'm gonna stop here and let you finish it. But normally this is very important for me to show, so I would show this. So you might be referring to something different.
Okay.
What do y'all think?
It's interesting.
Yeah, I mean, there's all these different ways you can go, right, with this. I mean, these identities are coming up. So you gotta practice a lot of problems to get comfortable with this. Okay. Ready for another one? Let's do this. Let me go real quick. I'm gonna go grab an old test and I'm gonna see something I've done before on a test. So yeah, I don't really care for that one. Oops. Why do I have 3 different reviews? This is weird. Oh, no. 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 Okay, well, then let me just do one. How about this one? Integral 1 over x squared plus 9 to the 4th dx. Now, I'm going to tell you right now, I just made this problem up, so I'm not sure we're even going to be able to do it, but at least we can get the trig sub going, all right? Let's see. So when we look at this initially, you're like, well, wait a minute, hold on. You said that trig sub is all about this, right? It's all about trying to see square root of a squared minus x squared, or a squared plus x squared, or x squared minus a squared. And I don't even see a square root, right? Let me see a square root. You know what? Let's change that 4 to a 2. Then I know it'll work. Okay. Change that 4 to a 2. So you don't see a square root, right? Not initially. But there's nothing else that we can do, right? You can't do basic U sub, integration by parts isn't going to work. We're pretty much stuck. So the key to this is to see this step here. Then you can rewrite this as the square root of x squared plus 9, all of that to the 4th power dx. Right? Because if I asked you to take some value, raise it to the half, and then raise it to the 4th, you multiply these two powers, and half of 4 is 2. So x squared can be written as the square root of x to the 4th, right? That's just algebra. And if I do it that way, then I do have this, right? I have this second case. So I can make my trig sub. X is going to be, in this case, a tan theta. So 3 tan theta. The dx is the derivative of this, which is 3 secant squared theta d theta. And the square root part turns into 3 secant squared theta.
Shouldn't it just be secant?
Oh yeah, see, oops, I was reading something else. Thank you. My dog is snoring. Y'all can't hear that, can you? You don't hear it? Okay, I just don't want it to be a distraction. All right, we good? Ready to rewrite this? So this becomes 1 over, okay, the square root part becomes 3 secant theta. So I'm going to have 3 secant theta. I'll go ahead and do it like this time. I'll put it to the 4th power. And then the only other thing I have is dx, which is going to be 3 secant squared theta d theta. And if I do this, I get 1 over, let's see, 3 to the 4th power times secant to the 4th power times 3 secant squared d theta. One of these factors of 3 cancel. So I still have 3 cubed down here. 3 cubed is 27. I can pull 1 over 27 out. And then in terms of the secants, I've got 2 factors here, which will cancel with 2 of those there. That'll leave me 1 over secant squared, right? 1 over secant squared, which is really just cosine squared, right?
Yeah, cosine squared.
Yeah. And then we can use the same thing we just did a second ago. That's power reducing. So we can go 1 over 27 integral. We have a 1/2 that comes out. This time it's 1 plus cosine 2 theta d theta. That's how we handle cosine squared. Pull the half out. 1 over 54 integral 1 plus cosine 2 theta d theta. Look, so this problem is actually going to turn out to have the same thing happen. We're going to need to use that double angle formula again, but any questions? Okay, antiderivative. So theta and then plus 1/2 of sine 2 theta plus a constant. Antiderivative of 1 is theta. Antiderivative cosine 2 theta is 1/2 of sine 2 theta. Right away, I know there's a problem here with this sine 2 theta. So I'm going to go ahead and use the Pythagorean identity, or not the Pythagorean identity, the double angle identity right away. And when I do that, I get 1/2 and then 2 sine theta cosine theta plus c. The 1/2 and the 2 will cancel. So I need to know what sine theta is, I need to know what cosine theta is, and I need to know what theta is. And earlier in the problem, we made our trig sub our trig sub, wasn't it? X was 3 secant.
I think it was tangent.
With the tangent, hold on, tangent. Forgot what we did. 3 tan theta. And so we will divide both sides by 3. We'll draw a right triangle. Theta tangent is adjacent over hypotenuse. I'm sorry, adjacent. Oh my gosh, opposite over adjacent. And then I can get the third side just using the Pythagorean. So this will become x squared plus 9. Yeah. And that's it. We have everything we need. Well, other than you need to solve for theta. This just take inverse tangent on both sides. So you get that. And so we should get as a final result here, 1/54. Okay, theta is inverse tangent of x/3. And then plus the 2.5 cancel. So sine theta is opposite over hypotenuse, x over square root of x squared plus 9 times cosine theta, which is adjacent over hypotenuse. So this will be 3 over square root of x squared plus 9 plus c. I'm going to clean this up a little bit more. I'm going to multiply these two fractions together and just get 3x on top, and on the bottom, because these are both roots, they multiply together, the roots go away. I get x squared plus 9 plus c. It's just a little cleaner that way. Do I have any questions? I feel like y'all aren't asking questions either because you're fine with this or you're overwhelmed with it. Which is it?
As much as I hate having 60 problems for homework, I'm glad that I have 60 problems for homework.
Lot of practice, right? Brandon, how do
Yeah.
you feel?
Overwhelmed, very
You feel-
well,
Okay,
all the whelmed.
yeah. Well, I promise you, the only way that you're going to get comfortable with this is if you do those homework problems and just it'll just start to click, hopefully, you know. And come
I
for
mean,
help.
the bit of the homework I have done, which I haven't been able to do it all yet, but there have been specifically like those reduction formulas. Those first problems in the homework were real heavy on reduction formulas. So
Mhm.
those are actually clicking a lot better, but it's like, yeah, I can see it. Like,
Yeah.
it helps.
Okay. So what I'd like to do here, I don't do this all the time, but I will, I'm going to differentiate this and just check it. Okay. Let's just do it fast. If I took the derivative of this, I'm going to put that 1/54. I'm just going to ignore the 1/54 right now. Okay. Just remember it's there. Okay. 1/50. Let me take derivative of this. There's 2 terms here. I'm taking derivative of each one. You know what? I shouldn't mess with that. 1/54. Let me just take this here. Put it down here and just act like this is what we're differentiating. So the derivative, you know what? I'm going to probably need this on a new page. Just remember, we got to hit this with 1/54 and we're done. Okay, so if I differentiate this, the derivative, I can do derivative of each one separately. So the derivative of that, well, derivative inverse tangent of something is 1/1 plus whatever's in here squared, x squared over 9, times the derivative of what's in here. Now be careful because that's really just 1/3 x. So the derivative of that's 1/3. So that's derivative of this. Plus, now this is a quotient. When I do the derivative of that, I need quotient rule. So derivative of top is 3 times the bottom minus the derivative of the bottom, which is 2x, times the top, which is 3x, all over the bottom squared. The bottom squared is x squared plus 9 squared. All right, let me go ahead and take this. What do I want to do with this 1/3? I don't even know what I want to do with this 1/3 yet. I'm going to combine these two together. And no, you know what? I'm gonna do something very unnatural, but I know where I'm headed with this. I'm gonna multiply the top and bottom here by 9. And when I do that, I'm gonna get, I have to distribute it through there. I get a 9 there, and then 9's canceled there. On top, I get a 9. On the bottom, I get 9 plus x squared. And then I still have that 1/3. I did that because I'm trying to get a 9 plus x squared on the bottom to look like this one, because I'm put them all together in a minute. And then plus up here, I get 3x squared. Let me just write it down. 3x squared plus 27 minus 6x squared. Right, so that will give me negative 3x squared plus 27 over x squared plus 9, that quantity squared. What now? I need a common denominator between these two. Let me go ahead and take this 3 on the bottom there and put it right there and get rid of this. So I'm going to multiply this bottom by 3, or that bottom by 3 and the top by 3. And then I have to multiply this one over here by a 9 plus x squared and a 9 plus x squared. I do that so they both have the same exact denominators. I know I go through these quickly, but this is just to verify. So distribute the 9 through the top, 81 plus 9x squared. And then over here, I'm going to distribute here. I get minus 9x squared. And then here to here, I get plus what, 54? Well, I'm glad to see a 54. And then on the bottom, I get, let me see, what the hell happens on the bottom? I just get the not 3, and then I have the x squared plus 9, and then squared. These cancel. What's 81 plus 54? 135? Is that right? Help me out here. 135?
Yeah, that's right.
135 over 3 x squared plus 9 squared. I'm guessing 3 goes into that. 3 goes in that once, 3 goes in, I'm gonna guess. What is it? It's got to be 54, right? It's not though. What is it?
45.
It's 45. Oh, was it a 45 we had out front earlier? I forgot already. What did I say we had up front?
I don't know, but the answer is 45.
We had 54 on the outside.
Okay, hold on. X squared. Hold on. X squared. This is what I'm getting here. Let me go back to what we were. There's 54. Oh, you know what? No, that's right. Right. 54. 54. What's going on here?
I don't know if this is what you did, but on the last page it was 3 times 27 and you put 54.
Oh, yeah, there it is. That's 81, right? Right here?
Yeah.
Yeah, okay, thank you. This time, why did I do that? I doubled it. I didn't triple it.
And you were just thinking 54.
Yeah, I just wanted 54 over that. That's 81. Good, thank you. 81 and 81, that's 162.
It works out if you do that.
Yeah, it works out, and then the cancels, you get 54, and then there's your 54. Okay, good. At least it was a little minor thing like that. All right. Okay, so it worked. You cancel out the 54 and you get back the original thing. All right, let's do another one. This one's going to be harder. Which one do I want? Let's do this one first. Right. This is different. All right. This is different. And the reason it's different is because the things that we've had, right? All of these forms we've had have always had a number squared minus x squared, or a number squared plus x squared, or x squared minus a number squared. We've never had an x term, have we, in there? Like if that was gone, right? If this was gone, then it would be this one, right? Because we would have like x squared minus a number squared. We'd have to factor the 9 out, wouldn't we? But we could do it. But that creates a whole different issue for us. Do you understand? Whole different issue. So what we have to do here first is complete the square.
Haven't
That
heard
means-
that in a long time.
Yep, haven't heard that in a long time. So I want us to do this on the side. I want us to take 9x squared plus 8x minus 8, and I want us to complete the square. Now, pay attention, because I know a lot of you have learned how to complete the square before. And I'm willing to bet that half of you are not going to know how to do this, all right, correctly. And it's not your fault. It's the fault that when you complete the square in algebra, you're always working with the equations. All right. So let's just work through this. Let's see if you can remember the steps. Would y'all like to see my completing the square steps for my college algebra class that I did today? I actually completed the square in that class today. I can give you here are the steps that I gave them.
What are you doing with the catapult, sir?
We were launching parabolas. We were talking about parabolas in the real world. Okay, so here we go. The steps to complete the square are as follows. First step is step 0, is you must have a coefficient of 1 on the x squared term, which we do not. We have a 9. So the first thing we have to do is factor a 9 out. And when you factor a 9 out, because these 8s don't have factors of 9, that means I have to take them and divide them by 9. So I do 8/9 x minus 8/9. And if you don't believe that's true, just distribute the 9 back through and you will get back what you had before. Okay, that's the first step. The next step, I'll bring these steps up in a second. I want to see if someone can guide me through the rest. Does anyone know the next step to complete the square? It's been a while, huh? You do something with this number right here.
You have to divide it by 2.
Divide by 2. I always like to say, instead of divide by 2, I always think multiply by a half. Because if you have a fraction, it's easier to think about it as taking that number and multiplying by a half. So I take positive 8/9 and I multiply it by a half, and I get 8/18, which reduces to be 4/9. So I get 4/9. And I always tell my students in college algebra, that's like our first magic number. Okay, we're gonna do something with this now. So what's the next step after you take that number and divide it by 2? Anyone remember? No. You take that answer and you square it. So you square the top and the bottom. So you get 16/81. And that is what I refer to as the second magic number. All right. This is the step that students have learned, and here it won't work. See if this sounds familiar. You're supposed to now take this number and add it to both sides of the equation. Does that sound familiar to you, completing the square? Take that number and add it to both sides of the equation. If it doesn't sound familiar, that's okay, good. But that's the way it's taught a lot in college algebra. The problem here is we don't have an equation. We have an expression, right? Look, this is an expression, it's not an equation. There's no two sides of anything here. So I can't add that to both sides. So what we have to do is something really weird. And that is we take this expression, and right after the x term, I'm going to add nothing. Okay, so I'm going to realize that right after this 8/9 x, there is a +0 and then the -8/9. I'm adding nothing, so it shouldn't change anything. But the way I add that nothing now is going to be really clever. It's going to be that number in blue here. I'm going to add it and simultaneously subtract it. And I hope you still agree with me that the part in red is still 0. So I haven't changed the problem, right? This is still 0. But by doing it this way, these first 3 terms, including just the first part of the red one, these will guaranteed factor to be a perfect square trinomial. Or I'm sorry, this is what we call a perfect square trinomial, which means it factors. And here's what it'll factor to be. Every time guaranteed, it will be something squared. It'll be this, it'll be x here. And the thing that goes here is that first magic number you got, which in this case was +4/9. If you put +4/9 there, you get, well, you get what you need, all right? If you don't believe that, just do it on the side here. X + 4/9, square it, so multiply it times itself. If you do this, you'll get x squared, you'll get 4/9x, you'll get 4/9x, you'll get 16/81, and then these two together will become 8/9x, and then you'll have that x squared out front, and you'll have the 16/81, and that in fact is those 3. So you don't need to verify that. I'm just trying to prove to you, yes, it will work. All right. Now we still have to figure out what these two together are. So I have to put this together with a common denominator. So that means I should multiply this top one by 9, this bottom one by 9. So I get -16. I'm going to take away, what is that, 72? I don't want to screw anything up this time. -16, take away 72. I should get -88 over 81. Are y'all feeling ill yet? All right. I'm going to do one more step. No, I think we're good. We've completed the square. I mean, I'm happy with this. I'm going to erase this though, because I need more room here. That's it. I'm not going to review completing the square any more than that. That's, if you want some more practice, you can come to my office hours. We can talk about it. All right. So now I go 1 over square root, and then everything under that square root just turned into a 9 sitting in front of an x + 4/9 squared minus an 81 over 8, sorry, 88 over 81, and then dx. I'll leave these steps right here, and that way if you look at the notes later, you'll have them there. Do you see that 9 right here that we got? That 9, I can pull that out of the root, can't I, as a 3? And then pull it out of the whole integral as a 1/3. So I have 1/3 integral 1 over. Okay, then I have x + 4/9 squared minus 88 over 81 dx. Any questions? What I've done here?
What happened to the square root?
Oh yeah, I don't know why I didn't write the square root. Sorry, I didn't write it.
Oh, my bad. Sorry.
Yeah, that would have been crazy. All right, so here's where we are, right? This is where we are. All that just to complete the square, just to get it to this. Now, watch what I do next. I'm going to do a quick U sub, just a quick U sub, not trig sub, a quick U sub. And you'll see why in a minute. When I do a U sub of the x plus 4/9, then the derivative of that is just dx, right? Because derivative of x is 1. So this is going to be a quick little like rewriting of this integral. It's 1/3 integral 1 over square root of, now this x plus 4/9 is u, and so it becomes u squared, and then minus 88 over 81, which I can't do anything with, and then dx becomes du. Now, the reason I did that is because if you now squint your eyes just right, you have to squint your eyes just right, then you can now see you have this. You have one of these. You have the first one. The last one, except we have this case, except instead of using x, we're using what?
U.
U, right? It's u's here instead.
We do all this to start the problem.
To start the trig sub now. Yeah. I tell you, I mean, Cal 2, it delivers on what it promises, right? It promises long, drawn out, difficult things. So, okay, so here we go. I'm going to make my trig sub now, and I'm not going to write x equals. I'm going to write u equals, because x is something else in this problem, right? All right, so u equals, and then I'm gonna do a secant theta, but look at a is a mess. A is the root of 88 over 9. So what I did is I just took the square root of that number. So I did square root of top and bottom separately. That's a, and then I have secant theta. The derivative of that u will be the root 88 over 9. Secant theta, tangent theta, d theta, and then the square root of that stuff, u squared minus 88 over 81, will be equal to a root 88 over 9 tangent theta. And then I rewrite the problem. Are we having fun yet?
Oh yeah, it's a blast.
Okay, good, good.
Hey, I have a quick question.
Yeah.
With that, you know, the x squared minus a squared equals portion, what do you recommend? Do you recommend we memorize it per type, or do you recommend we figure out and remember our the way to actually find it?
Okay, I personally don't have them memorized. Okay. I can derive them if I need to. Okay. Right. If I were a student taking a test, see, me personally, I'm not a big memorized person. All right. I'm not a big, my brain doesn't like to do it that way. So if I were doing it, I would just say, I'll derive it during the test. If I were taking the test, that's going to eat up time though. But if you're a person who memorizes real quick and easy, just memorize it. You know, it's just me personally. I don't do it that way. So I think it depends on you, really.
Okay, gotcha.
Yeah, and I allow you to use a lot of formulas in this class. There are some calculus instructors who don't let you use much of anything. So I'm not asking you to memorize a lot. The one thing I'm here asking you to memorize, you can actually, you don't even need to memorize, you could derive it. So, you know, I hope that addresses your question.
But like for sure, you do it so many times that you'll just like, I get it now.
Yeah.
You know, like 63 problems is enough time for you to like understand. Like,
but everybody's different, you know. Some people, you know, they can just store information that way easily, and others don't, you know. So okay, so I've got my 1/3 on the outside. I've got 1 over, then the square root thing becomes the root 88 over 9 tan theta. Please be a good integral. Okay, and then I have du, which is root 88 over 9, secant theta, tangent theta. Oh yeah, this is gonna be good. This is gonna be good. Because the tangents go away, the roots go away, and all I'm left with is the secant theta, right? That's it. Integral secant theta with a 1/3 out front. So 1/3 integral secant theta d theta. And fortunately for us, we did that in class and we know the answer. It's actually on our formula sheets, right? The antiderivative of secant theta. So let me go look at it. Antiderivative of secant theta. When I show it to you, you'll remember us doing it. It was that one where I said someone spent a bunch of time trying to figure out what to do and they multiplied top and bottom by this weird thing. And so it's natural log secant u, tangent u. In this case, we're doing theta. So that's what I'm going to do. So this is going to become natural log of secant theta plus tangent theta. It was plus, right? I believe it was plus c. I'm out of room. And now I've got to get back to x, right? I've got to get back to x. And so to get back to x, I need to know what secant of theta is and tangent of theta is. So I go back to where I did my trig sub. Here was my trig sub right here. And notice in my trig sub, I have the variable u, right? Not the variable x. So what I can do here is multiply both sides by 9 and divide both sides by root 88. And that gives me what secant theta is. So if I do a triangle like this, and this is theta, secant is hypotenuse over adjacent. And that means the one remaining side over here is the square root of this one squared, so 81u squared, minus this one squared, which is 88. So now we have 1/3 natural log. Okay, secant theta. Oh, well, I already knew what secant theta was, didn't I? Right there. I knew what it was. It's 9u over root 88. And then plus tangent theta, which is opposite over adjacent. Square root of 81u squared minus 88 all over root 88. Close the absolute value. I mean, sorry, close the natural log. Yeah, close the absolute value in the natural log. And then we have to go back and replace u with what u was. And u was x plus 4/9. I'll just write it here. U was x plus 4/9. So I'm just going to write that out. 1/3 natural log. All right, 9. And then u is x plus 4/9 over root 88 plus square root of 81. And then I have to take that x plus 4/9 and square it, and then minus 88. And then all of that is over root 88. Close it off, plus c, box it up, I'm done. I could do more algebra in there and clean things up and, you know, distribute the 9 through, and I could actually expand the x plus 4/9, square it, distribute an 81, clean it all up, combine these two together with common denominator. They already have the same denominator. I could rationalize a denominator. There's a whole bunch of stuff I could do algebraically at this point, but this is all I really need. I've come to the end here. I've got it in terms of x. Yikes, huh? Yikes. So let's just recap this problem. started off, the X term was the thing that made you go, ah, crap. Got to complete the square. Complete the square, rewrite it. Okay, pull that 9 out as 1/3. Okay, this, you got to kind of go, oh yeah, that kind of does look like one of those trig subs, but this X plus 4/9 needs to be changed to something. So we change it to a U. Now we've got this, we got the trig sub, go in, and then, you know, everything after that, just working with the triangle.
That one was nuts.
Yeah, yeah. So I'll give you an example. I'm not going to do this one. I don't have time, but here's an example of a problem in the homework set. I don't know if this is on homework. It's number 64, but it's well, you know what? 62 x squared over. It has 3 plus 4x minus 4x squared, all to the 3 halves dx. Which is really just, that 3 halves really means square root of this cubed. And so the first thing you have to do is complete the square on this, because you have a middle term there with an x. You have to complete the square on that. And then once you complete the square on that, you're going to get something that looks like one of those 3 things. So you have to do a basic U sub like we did in the previous problem, and then do your trig sub, and then plug everything back in. This is a good problem. I wonder, do I do this one on the homework solutions 62? I'm going to see. I'm going to see if I do.
I need to find the best way to learn math. I'm going to get my formula.
61.
Natural log U. Which
That looks like the one we just did.
squared my square root part.
That's very similar to the one we just did,
Lets you work this out.
but I didn't do number 62. All right. Okay, we must move on. We must move on. Make sure you do your homework for this section, right? Let's look at the calendar real quick. Today is the 16th. We're on track here, right? We're not behind. Since we're not behind, let me do this. Let's do this last one. Why don't you try this one on your own? I'm going to put you, I'm going to put you all in breakout rooms. I don't normally do that, but this topic is so important. Like if you can't do this on the test, you're going to fail the test, right? So let me give you that problem. Make sure you have, I'll put it back up there. Make sure you have this handy. All right. And I'll give you, I don't know, 20 minutes. I think that's plenty of time, but let's see. Breakout rooms. Where are my breakout rooms? Breakout rooms. There will be 3 to 4 of you in each room. Be nice to each other. Help each other out. Don't be silent, but then also don't overwhelm everyone. You know, let everyone have an opportunity to talk. But talk to each other, all right? There you go. Join. We'll come back. I'll pull you all back in a little bit. Oh, I didn't open them. Sorry. I made them, but I didn't open them. There they are.
Professor,
Yes, sir.
is it okay if you can enable screen sharing, please?
Oh, yeah. I don't know how I'm going to do that. Hold on. I'll try.
Trying to get a meal in. That's why I always mute my camera, because I like to eat coming out of the gym. You could always switch it off like after the module.
All right, see if that does it. It may or may not.
Negative.
No?
I'm sorry. Participation screen sharing.
What?
Participation screen sharing.
Yeah. Allow. people to join.
If it's not, that's cool. We can do it on a separate note.
Yeah, it may not be something, it may not be something I can do right away. It might be that we have to restart the rooms.
Probably.
I would just go back in there and talk. I'll work on it while y'all are, trying to talk to each other.
I'll go ahead and periodically check on it. All right, thank you.
Okay. Louis, did you come back and say something? Hey, what's up, Louis?
My computer died.
Oh, okay. We're only gonna go about 5 more minutes, so,
Never mind, I'll just stay here.
okay.
Professor, now that I have you real quick, so the questions that I was asking in the homework, those,
Yeah,
those, you would finish them out in the video, but this is 6.1, this is in part 2 of 6.1.
Uh-huh.
So in like the first, let's say like question 11, you use like a trig identity.
Oh, yeah, the T sine square T?
Yeah,
Uh-huh.
so then you end up having like, 1/2 1 minus cosine t squared. And finishing it up. Well, actually, a better question would be, do you want me to go ahead and just finish it out like the right way, or?
I'm not sure what you mean.
Like, for example, in the inside of the integral, you have sine of 2t minus 1/8 cosine of 2t. So those 2t's inside of the sines, you want to go ahead.
So are you referring to what I did on my video?
Yeah. I'm just
Okay.
referring to what you want the answer to be.
Okay. Give me a minute here. I gotta close these breakout rooms. I can't find them. Where the hell are they? Where are the breakout rooms?
And let's say theoretically, like you wanted us to close. Never mind. Sorry.
Okay, let me bring this over here. I've got to look at what I did in my solution so I can
So I've got my essay written, and I'm
tell you.
because I like the derivative. And
It's
this
11.
plus. Here, but then it's confusing.
All right, so I rewrote this and then distributed through. And then I took antiderivative of each one.
You want to share in your screen, sir?
Oh, I'm sorry. What did I?
Hey, Professor, I had some questions about about this one that I wanted to see. Like, I want to see how far I got and see if I was right or wrong.
Which one are you referring to? The one I just
Integral
typed
of,
out there?
yeah,
The one in the breakout rooms?
yeah.
Yeah, okay, yeah, we're gonna talk about it. Hold on a second, I'm addressing a different question right now.
Take your time. Thank you.
Let's see what I did here. Yeah, so there's a lot going on here. I did integration by parts first, right? So Louis, I'm just not quite sure what you're asking me in terms of the final answer.
The final answer you have inside, you can see it as 2t inside of. It's
Oh yeah,
side
that's
of 2t.
okay. That's okay. That's perfectly fine. Because our original variable in the integral was t, right? So if our answer is in terms of t, we're fine. Right?
Oh, I'm
The
so sorry.
reason why we have to do the 2 theta back to theta is because we're trying to get back to the original variable x.
I'm so sorry. My bad.
Don't apologize. I wasn't understanding, but now I understand your question. Okay, now the problem that I just gave you all to look at. So the substitution here, x is equal to, you're going to use the a tan theta, right? So this should be 4 tan theta. The derivative of that should be 4 secant squared theta d theta. You know what? Hold on. Do I don't have this. Okay. And the square root part should turn out to be 4 secant theta. And so when you rewrite the numerator, you have to do x to the 5th. So that's, I'd write it this way, 4 to the 5th tangent to the 5th theta. That's the way I'd rewrite 4 tan theta to the 5th. I just raise each one to the 5th. And then on the bottom, I've got the square root part, which is just 4 secant theta. And then the dx would be 4 secant squared theta d theta. And then I get a 4 cancels here. I get one of the secants goes. So I'll bring a 4 to the 5th to the outside. I'll figure that out later. I've got a tangent to the 5th, theta, secant theta, d theta. And then I go back and I go, okay, I've got tangent to an odd power, right, with secant mixed up. So I'll pull one factor of tangent off and make it tan to the 4th theta. Then the rest will be secant theta, tangent theta, d theta. And I'm going to rewrite tangent to the 4th as tangent squared, and then rewrite tangent squared using the identity. I'm trying to get everything to secant because I know that this is the derivative of secant. So of secant theta. So I'm going to rewrite this as secant squared theta minus 1 squared. That's tangent squared rewritten and then squaring it. And then I still have secant theta, tangent theta, d theta. Now I make a basic u sub. U is secant theta. Du is secant theta, tangent theta, d theta. And if I do that, my new integral becomes u squared minus 1 squared du. It's a direct, I don't have to scale or anything. Joshua, so far, Josh, this okay? Thumbs up? Yeah.
Yeah, I didn't realize I could, I kind of made a dumb move, which is where I didn't use, since it was 4 tangent theta was equal to x. I didn't think to substitute that into x to the 5th. I had the denominator right, but then I ended up, I'd have to show you, but yeah, I went different directions. So
yeah, you got to make sure that when you make the trigonometric substitution, right? When you make this trig sub, that means your new integral has to have just thetas in it, right? Just thetas, no more t's, or sorry, no more x's. All right, so we're almost done here. Then this becomes antiderivative 1/5 u to the 5th minus 2/3 u cubed plus u plus a constant. And then u is secant theta. So 1/5 secant to the 5th theta minus 2/3 secant cubed theta plus secant theta. So I need to know what secant theta is, obviously, right? And do I know what secant theta is? I've got to go get it off this. I'm going to go get it off that. So that's x over 4 is tangent theta, which means I'm going fast because I'm almost out of time. Make my triangle. I should have this theta, right triangle. So secant is going to be the reciprocal of cosine. So it'll be this root thing over 4. Okay, so I've got, yeah, it's ugly, 4/5, 4 to the 5th times 1/5, and then I've got square root of x squared plus 16 over 4, all of that to the 5th, minus 2/3, and then the same thing, square root of x squared plus 16, all over 4 to the 3rd, and then plus square root of x squared plus 16 over 4 plus c. There we go. Okay, all right. Well, we didn't get into the next section. That's fine. I really am just trying to kind of, I don't want to get too far ahead because I want you to have time to absorb this. So make sure that over the weekend, you really take time to get through those exercises for 6-2. You know, reach out if you need help. And then next time we'll get into 6-3. Partial fractions, I will try and find a video to remind you of what partial fractions is about, but you know, see if you have your notes laying around too. I will briefly cover it. It's not like I'm going to just go and just expect you know how to do it. I'm going to kind of remind you of how to do it, but you need to have some idea of what I'm trying to accomplish. Okay, everyone, have a great weekend.
Sir, before we go,
Thank you.
are you?
Hey.
Sir, I had a very dumb question.
Well, go ahead.
So I made the connection, right? I was in my work, I was doing everything right until the U. Like I know it's wrong, I know my answer's wrong because I totally forgot the U, but I went straight to the antiderivative.
From here.
From, yeah, there.
So how did you go to the antiderivative here?
So I took each part.
Mhm.
So with inside the bracket, I took each part. So the secant square theta would just be tangent.
Okay, I see what you're
And
doing.
then theta, and then that would just be secant. Because I was thinking to myself, when I was up in there on the red, I was like, do I have to do U? And it felt like I was missing something when I finished it too. But
Well, the problem is that, you know, when we have an integral, if you have, you know, something plus something, right? And you want to know the antiderivative, then you can just do each one separately, right? You can do the integral of that one, the integral of that one, the integral of that one, and you're fine. As long as there's pluses or minuses, you're good to do that. But if there's multiplication, you can't, right? So if you have something,
okay.
something, right, then this is not okay to do the integral of the first part times the integral of the second part. That's not okay. And that's what you would have been doing here, right? Because there's multiplication right there. And not only that, this squared means that this is multiplied too, right? It's like this times itself. So you can't even do it on just this piece because of the squared. Make sense?
Yeah. I just wanted to know, like,
Yeah.
I know it's wrong, but this explanation is good. Alrighty. Thank you, sir.
All right, good
Keep
luck
up the
with your
cardio. Let's see.
homework.
Thanks, sir. Have a nice weekend.
You as well. Any other questions, Sam? No?